Yeah, so hello everyone, welcome to Legacy IAS. Today we'll be starting class 7th Science and Tech NCERT. Again, the curiosity series continues. Okay, this is for grade 7. Okay, let's look at the main contents. What are there? Now, so these are the contents of the book. Now, if you start looking at it, first it talks about the ever evolving world of science. Okay, this is a very basic chapter, just telling you about that what you had learned in class 6. Now some more things we'll learn. This is like an introductory chapter. Now from here we'll get to the main chapters, which is chapter 2, acid, bases and neutral substances. Then there are some chapters of physics, chemistry, biology, all that you will see in some time. So let's get started with the first chapter. Nothing much here. Okay, the ever evolving world of science. It just continues from the sixth class NCERT. Now, so it is asking you that what are the different kinds of acids that are present here. Okay, all that you will learn in the second chapter itself. Okay, so there is orange. Orange has what acid? Citric acid, all that. Then raw mangoes, tomatoes, all these. Then it talks about circuits. Correct. So this is a complete circuit. It can conduct electricity. Correct. This is a plus minus battery. A bulb is there. A spoon is there in between. Now why it will allow the electricity to pass. All that. Okay. So basic introduction of all chapters. Then it talks about how our body changes. Correct. As we grow older, especially in the adolescence. Then it talks about electric clocks, watches. Then it talks about sun, earth, eclipses that are caused, lunar eclipse, solar eclipse. Just introducing, nothing much here. So this is chapter 1, happy exploring. Let's get started with the main chapter 2. Now, first thing it does, it actually poses a question to you. That, so it tells a scenario in which the student has done what? He has a white sheet of paper, okay, and on that white sheet of paper nothing is visible. Then he throws something on it, okay, he sprays something on it, and suddenly the letter starts being visible, and it is written, welcome to the world of wonderful world of science. Now how did that happen? What might be the reason, or what might be the science behind it? This is how it starts. Understood? This basic framework is clear, what we are trying to find. Okay, at the end of the lecture you will answer this yourself. Now, so first it talks about the National Science Day, a fair is going on. Then it comes to the main things, which is first of all the most important. I think this is important for UPSC also, as in it can be asked directly. Okay, this is about indicators. Okay, what are indicators? At least some name you might have heard. Correct. You might have heard of at least litmus. Correct. Litmus test. Okay, so all that we learn here. Now it says you take a blue litmus paper. Now, using this blue litmus paper, you put different substances on it. Now, now, first it says, first it asks you to use lime water. Now, first thing, should not confuse this with lime. Lime is like a fruit, not that. It is, when we say lime in chemistry or in science, it usually means lime water, or or in other words, this is called CaOH whole plus, this that I have written here. Okay, now what is this? This is actually basic in nature. Okay, so it is starting with indicators and then it will define acid basis. If you remember, acid basis we have done in class 6 also, basic things. So basically that acid is something that you know is little sour in taste, correct? And one thing more, that it releases H plus. Then what was base? What was base? So base was something that releases OH minus ions, correct? And it used to be bitter in taste. Now, so first thing it is talking about this only. See, It is telling you how lime water or the CaOH whole twice is made. So it is actually made using this CaO. Okay, this is tuna, or in Kannada, I think you call it sunna. Okay, that white substance. Okay, that you use for as the initial paint of your wall. Then you mix it with water, it becomes CaOH whole twice, which is lime water. Now, remember this about the litmus. Simple mnemonic. This will help you remember it. This is ABR, that is acid returns blue litmus. If you take a blue litmus, that will become red. So that is why I remember it as ABR. Simple. The opposite of this is true for base. So base will turn red litmus blue. Base will turn red litmus blue. Understood? While if you put, let's say, blue litmus in base, nothing will happen. Similarly, this in that, nothing will happen. So this is how you have to identify. Now, it is giving you a test, fairly easy. Lemon juice, what is it? You might know that this is sour in taste, correct? So this is acidic. Now, 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 if you put blue color litmus in it, what will happen? Blue color litmus. So acid turns blue litmus red, correct? So this will become red. Okay, and then this is no change. Similarly, soap solution here, it will not, it will turn red litmus blue. So this will turn out to be blue. This will remain as it is, correct? Similarly, all you can do. Then now let's understand what is a litmus. So litmus is what? This you see. See, litmus is a natural substance. Okay, now litmus is obtained from something we know as lichens. What are these? These are actually combinations of a, yeah, a fungus and an algae. So this you might have seen near trees and all that. Okay, fungus or algae. This is lichens. Okay, now now what they have a, from this you make something known as litmus. Litmus property you have already understood what it does in acidic solution, what it does in basic solutions. Now same thing is written here. Since litmus shows different colors in acid base indicators, that is why it is called an indicator, or it can indicate if a thing is acidic or basic. Now, next is natural and synthetic indicators. So basically, what you learned here, that is litmus or lichens, that is what you're getting it from biological things, correct, or natural or living things, correct. This is called natural indicators. What you make in labs and factories, that is called a synthetic indicator. We learn about synthetic indicators also. Then it talks about what is lichens. This we have already understood. Now one more thing it talks about, this is important. So basically, this lichens is in a symbiotic relationship. We'll learn about it later, between fungus and algae. So basically, these two are living together. They are like flatmates. Now, one of them actually makes food. So alga can actually make food. It is like it can do photosynthesis and all that. Fungus provides it the nutrients to make food. So you understood that both are mutually dependent. That's why they live together. Now, this lichens has a special property. First, it shows that the area has decent amount of rainfall. Then only you will have lichens. And the other thing is about the air, or there must be clean air, or there should be pollution free environment. It only grows in a pollution free environment. So it is an indicator not just of acid and bases, but also of how is the environment around. Understood? This is given. They grow on rocks and trees in regions that have abundant rainfall and clean air. Okay, then let's see next. Now they come to defining acid and bases. So what are acids? Acids are something that taste sour, and are acidic in nature, not acidic in nature, but they release H plus ions. Okay, we'll understand what are these ions, how they are released in some later classes. Now, that question you remember in first chapter we saw this, correct? So its solution is now given. So this has citric acid, this has ascorbic acid or and some citric acid only. Then this is raw mango. So raw mango has tartaric acid. Then this tomato has citric and oxalic acid. Then now let's find out the different kinds of common acids that are present in substances. So there is lemon, curd, tamarind, vinegar. Now, what are these acids? So I have written in short. Lemon has what acid? This is citric acid, correct? Curd has what? Curd has very famously lactic acid. Tamarind has tartaric acid, and vinegar has acetic acid. Acetic acid is actually very dilute form of acetic acid becomes vinegar. Okay, now so these are different kinds of acids. Now, what are bases? So base are something that are slippery to touch. Okay, they are slippery to touch, and what they release? They release OH minus ions. Fine. Then now bases you have understood what base will do. It will turn red litmus blue. Now one more thing is there that everything that is bitter, it does not mean that it will be a base. Correct? That does not mean it will be a base. What decides if something will be a base? That depends on if if it can release OH minus ions or not. If it can release OH minus ions, then it is base, otherwise not. Then yes. Then next we come to red. Red rose as an indicator. Now see. So you understood litmus, how litmus was working. Similarly, red rose can also work as an indicator. Okay, now see how it works. So this is what happens with red rose specifically. Okay, so this is about red rose. So red rose will do what? It will turn an acidic solution. If you take red rose extract and you put some acid on it, or this you put in some acidic solution, same thing, it will turn red, while it will turn a basic solution green. So that means red rose extract can also be used to identify both acid as well as base. Fine. Then now similarly, there are many substances like this. There is turmeric, jamun, gudhal is a flower. All that can do similar things with respect to acid or bases. Then it talks about a very good flower, very special flower that is found mainly in the northeastern and Himalayan regions. Now, what it does, this flower's color actually depends on what kind of soil this is. Okay, so it depends on the kind of soil. Now, if it is an acidic soil, then it produces blue colored flowers. If it is a basic soil, it will give pink or red color flowers. So even the color of flowers is, in this case, is being decided by what kind of soil it is. Understood? Then next it talks about turmeric as an indicator. Okay, now Turmeric, you can use it as a paste also and as paper strips also, does not matter. Now, now it is asking, can turmeric paper be used as an indicator for acidic substances? Now, this you need to understand. So turmeric does not change any color for acidic and neutral substances. So this you can't differentiate. You cannot differentiate or guess what is an acidic substance based on turmeric. But what it can do, it actually turns in basic medium, it turns red. Turmeric turns red in basic medium. This you might have seen when you are washing clothes. When you are washing clothes, you must have seen yellow patches because of turmeric. Now, when you wash it with soap, it suddenly becomes reddish. Correct? That is actually why, because turmeric is like an indicator, and in basic medium, which is the soap, correct? Soap is slippery to touch, soap is basic, it will turn red. Correct? Now, it also talks about some facts about turmeric. Important, can be asked anytime. Now, so what is turmeric? Turmeric is called a golden spice. It is called a golden spice. Now, it is a member of ginger family. Please remember this. Ginger, you understand? Of course you do. So this is also grows similarly or looks similarly like ginger. That's why it is called to be from ginger family. Now, it is grown in India and other countries. Now, turmeric is said to have numerous Ayurvedic properties, Ayurvedic or health benefits it has. Like you, when you get ill, okay, because of some cough, cold, whatever, you're given haldi doodh or turmeric milk. Okay, now it also talks about this. We'll see that there are certain things that can change their smell based on, they can change their smell based on if they are put in acid, acidic thing or basic thing. These are called olfactory indicators. Okay, what they do, basically you can smell from their odor that they are in an acidic medium or basic medium. Now, then it talks about know about a scientist. So he's talking about very important PC Ray. So PC Ray, okay, you might have read about them in modern history. Okay, in modern history you must have read about him. He, see what all he has done. This you might have learned that he also established India's first pharmaceutical company in 1901. Now, what other things he has done? He is known as the father of modern Indian chemistry. Fine. Then, through his writings on history of chemistry in India, he highlighted what we had achieved in the ancient India with respect to chemistry. Then, he was also a social reformer who advocated that students should be taught in their mother tongue in educational institutions, especially the primary education should be in the mother tongue, so that the child is not getting frightened because of the language itself. He focuses on learning the subject. Then it talks about what happens when acidic substances mix with basic substances. What will happen? If you know anything, you know about neutralization, correct? So they will become neutralized, or acid plus base makes for a salt, and some amount of heat also is generated. Now, let's see this. So it gives you an example that, let's say you have lime juice here, lemon juice here. Lemon juice will be what? Lemon juice will be what? Lemon juice will be acidic in nature. So if you put blue litmus in it, blue litmus solution in it, what will happen? It will become red. This you can feel, correct? Now, I add lime water in this. Lime water is what? So lemon juice is acidic in nature, while lime water is basic in nature. Now what will happen? Lime water is basic, this is acidic, so they will neutralize each other. Once they neutralize, what will happen? The original color of the blue litmus is what you will start seeing. Understood? So it talks about lime water has neutralized the effect of the acid. Now this is the reaction. Any acid plus you add base in sufficient quantity, it becomes salt plus water plus heat. The reactions we are not getting into at this level. So acid, you take any acid, okay. Okay, if you want reaction, let me write a reaction. So this is HCl, let's say an acid, then plus, let's say a base, let's call it NaOH. Can you see here you can release H plus, here you can release OH minus. Now if you add them, what it becomes? It becomes NaCl, which you know as common salt, correct? This is what you eat plus. Now see what is remaining. Cl and Na are gone. So what is remaining? HO. What do you think? 2HM and 1O? H2. Okay. As you can see, salt and water and some. Understood? Then it talks about neutralization in daily life. So what is this? For example, if a red ant bites you, then what happens? So basically, the red ants bite is actually what it does, it releases formic acid inside you, and because of that you feel that stinging sensation. Now once formic acid is released, what you have to do, you just add moist baking soda to it. So if you add baking soda to it. Now what is baking soda? What is baking soda? Baking soda is basic in nature, correct? Baking soda is basic, this is acidic. What will happen? What will happen? Neutralization reaction, and when it neutralizes, what you will start feeling? You will start feeling much better. Simple. Then then it similarly talks about the soil also. So if you use excessive of fertilizers, over a time what will happen? Over time your soil will turn acidic, correct? Now how do you treat this? So you can add same lime water, or in chemistry we usually just call it lime. So this is CaOH whole twice. What is this? This is basic in nature, correct? This is basic in nature, and this will neutralize the acid. The soil will become good and fine again. Then then so acidic you understood. Now if the soil is basic, what you do? So if the soil is basic, what you have to do? Basically, you can add any organic matter like manure. So in manure actually there are bacteria which will, when they eat parts of it, it releases small amount of acids, or it is slightly acidic in nature in simple way. Then it will neutralize the basics. Very simple. Now sometimes the soil may be neutral, but still it may be showing some poor head, which may be due to deficiency of some nutrients. So that it is not that always it is acidic or basic, that only is the problem. There may be some other issues also, that some nutrient is not present at all, correct? So those all are there. Then now you tell me the final question. What do you think was on that paper? What do you think was on that paper, because of which when he threw some, sprayed something, the letter started being visible, which was not visible earlier. Now you think that it may be that the paper had turmeric on it, correct? And something was, now if it was turmeric, now if I throw turmeric, does what? Turmeric can turn a basic solution in red color, correct? So what I will do, turmeric, it was all looking yellow. Now what I do, I write on it using, let's say, soap solution, correct? Or I can throw soap solution on it, and then what will happen? The parts of turmeric in the white page, so white page is looking fine, but the parts where there is turmeric, that turmeric will turn immediately red, and from that you can see the letters. So this might be the thing that was mentioned at the start of the lecture. Okay, then this, so imagine there is a garden. Now the soil can be acidic in nature, it can be basic in nature. Now how you can test them? Using litmus. Now if it is acidic, you treat it with lime water. If it is basic, you treat it with mineral. Simple. And some more activities are given like this. Then we come to the next chapter, which is electricity, circuits and its components. Very basic, we have to understand. Okay, now see this. This is important, not from science and tech, but I think this can be asked directly as a question. Okay, because there is a very famous dam called Bhakra Nangal Dam. Now, the thing about this dam is actually it is based or it is located on the borders of Himachal and Punjab. As you can see here, 313-kilometer train ride from Nangal in Punjab to Bhakra in Himachal Pradesh. Okay, then it also tells more about the location. So this is based on Satluj River and what kind of mountains? It is on the through the Shivalik mountains. Correct. So please remember Bhakra Nangal Dam, border of Himachal Pradesh and Punjab, and Nangal is in Punjab, Bhakra is in Himachal Pradesh, flows on Satluj River and Shivalik mountain ranges. Then the chapter is not so. Chapter is much more different, which is about electricity. Now, electricity, where do you use it? All these places, all fine. Now, it says that in this chapter we'll mainly focus on using batteries or cells only instead of using the socket, because that can be dangerous for children, for you also. Now first it talks about torch, okay, and then it tells that sometimes it is turned on and sometimes it is turned off. Now what is this phenomenon? Okay, now see, yeah, see this. So there is a simple electric circuit. Now, a simple electric circuit we'll understand. Let's understand small components. Components you know of. So electric cell, correct? Electric cell has a positive terminal and a negative terminal. Now, all electric cells will have a positive terminal as well as a negative terminal. Now, now what happens? See this. So this metal cap like structure that you see is the positive terminal. This flat structure that you see is usually the negative terminal. Now, in general, if you might have noticed, we don't use a single cell, correct? We use combination of cells. We use combination of cells, which is called battery. Okay, battery is a combination of cells. Then now you come to electric lamp. So what is an electric lamp? Okay, so this is incandescent lamps. This is a normal bulb that you might have seen. Now it has many different components. For example, filament. Okay, this is wire, this is metal casing, this is metal tip. Now what is important to us? That you see. So filament is important to us. What is a filament? Filament is a thin wire that is inside the glass bulb and it glows when electricity is passed through it. Just by generation of, it leads to generation of heat also and it glows. Now that glowing is actually made even better by this bulb that is around it. And this is how a normal bulb used to work. Correct. So here the terminals are not fixed. Okay. So basically what you do, you just take this bulb, okay, and you connect it to a battery and it will start glowing up. Understood? Now, but you have something known as LED lamps also. What is this? This LED means light emitting diode. Now, let me tell you about diode. So, diode is something where current can pass only in one direction. So, these are unidirectional in nature. This is what you call diode. Only in one direction current can flow. Now, see, in LED, there are two kinds of wires. So there you didn't have any positive, negative within the bulb. You didn't have. But here you have a positive terminal and a negative terminal. The positive is usually longer, this is little smaller. Now, LEDs do not have any kind of filaments. They have proper terminals, positive and negative. Now what happens? Let's see. So you take a battery. Okay. Now this battery, you try to connect it to different kinds of incandescent lamps, incandescent labs, or LED lamps. Now see what happens. Now what you see here is called an electric circuit. So what are the components? There is battery, positive, negative, and there is a bulb like this. Now we consider that electricity or current flows in from positive to negative direction. Correct? This is a convention that it flows from positive to negative direction. Now, see, in this it says that in this old lamps, it does not matter whether you connect it here or there. Why? Because it allows flow of current in both directions. So it does not matter, correct? So here, if this is positive, the bulb will allow it to flow, correct? If this is positive, the bulb will again allow it to flow. It does not have its own terminals, correct? Now, now, but But if you talk about LED lamps, in LED lamps, because it has positive and negative, so here the positive must be connected to the positive terminal, negative must be connected to the negative terminal, then only there can be flow of electricity and the circuit will be completed and the bulb will flow. This will not work. Understood? Now, it also talks about this, that sometimes you call that bulb has gotten fused. What is that? That is usually a broken filament. So then if the filament is broken, what will happen? The circuit won't be completed, correct? And that's why there will be no flow of current. So you understood the difference between the two? Then next thing. So it says that if you have batteries kept parallelly like this, don't be confused. The connection will always be like positive to negative, as you saw in the batteries, positive to negative. Positive, negative are always connected together. Then, then it talks about electrical switch. What is an electrical switch? Here they are using a safety pin as an electrical switch. Electrical switch is very simply a device that can either complete a circuit or break a circuit. So this is like what you call off, correct? Because it is not completing the circuit. This is what you call as on, because now the circuit is complete. Fine. Then there are circuit diagrams. Electrical cell is made like this, battery, then lamp. Not very important to us. Light emitting diode, because it has one directional flow. That is why they are made like a triangle. That it must flow like this. Then you have on, off, wire, all that. The symbol of LED is a triangle, as you can see, positive to negative, because flow direction is also being shown very clearly for diodes. Okay, these diodes are now used everywhere. LEDs are used everywhere. We'll read about them in higher classes even more. Then it talks about electrical conductors and insulators. This we had seen before also. For example, here it has connected steel or let's say metal here. Now what will happen? The circuit is still called complete. Why? Because this will allow the flow of current, correct? So anything that allows flow of current is called a conductor. Fine. Anything that does not allow flow of current, for example, rubber and all that we had seen, these are called insulators or poor conductors of electricity. Simple. Now, it says that silver, copper, gold, all these are very good electrical conductors. However, why we use copper mostly? It is not rocket science, it is not very difficult, because copper is cheap and much more easily available. That's why we use copper. Okay, then it says that insulators are always useful, also useful. Why? Because see this wire may be made of copper, but it must be surrounded by plastic casing or rubber casing. Why? Otherwise when you touch this wire you will get current shock. Why you will get current shock? Why you will get shock? Because our body is also a conductor of electricity. That is why you might have seen in some movies that one person is trying to switch on something and he started getting current in his body. Now somebody else also touches him, he also starts shaking. Why? Because all human bodies are conductors of electricity. Then it talks about that there are two kinds of currents. So there are some batteries which use direct current, and the current that you get in wall sockets and all is called alternating current. Now the real difference between them we'll read in higher classes. What are they? There is proper difference between them, that is direct current and alternating current. Then it just summarizes this very simple chapter, okay, for us. That's it for this lecture. Thank you.